We're going to calculate the distance from a point to a plane. First, we're going to do an exercise in order to illustrate this, and then we're going to generate a formula that you can use the formula, or you can do it in a structured manner, like we're going to do it in this way. Alright, so first we want the distance between the point P 1, 1, 3 and the plane 3x plus 2y plus 6c equals c. If you think you can do it, stop the video now and next continue to see if we have the same result. Alright, so we have the plane and we have here a point. We want to know this distance, that's the shortest distance. So it's the plane, a point, and we want to know this distance. How we can know this? We are going to select a point that lies in the plane. So this is point P1 if you want. We are going to select a point that lies here in the plane. Here, let's say P0. We are going to calculate this vector, the vector P0, P1. So would be just the distance between this and this would be the difference of the components. We are going to go to that. Then after knowing this distance, this vector, you see that the projection of this vector onto this line is going to be the distance. So we have this vector, the projection, and remember we have the scalar component and the, or you can say the scalar projection and the vectorial projection. The vectorial projection is the vector of this projected onto this. That would be the scalar projection or the scalar component multiplied by the vector. So we don't want a vector, we want to know the distance, we want a scalar number. So it would be just the scalar component or the scalar projection of this vector onto here. If this do not seems clear to you, you can review the video of the dot product. Alright, so we know that the vector PO1, this PO1, if you calculate the projection, would be here. We want the scalar projection, so remember POP1 dot let's say this, that actually is the normal vector, as you can see, because here is the plane, here is a point. We want this distance, but as you can see, it's in the same direction as a plane, as a vector that is normal to the plane. So you could see this vector dot this vector n is equal to the magnitude of this vector times the magnitude of the normal vector times the cosine of the angle. And we want to know the scalar projection of this vector onto this normal vector. So the scalar projection is the scalar projection of this vector onto this vector is just the magnitude of P not P1 times the cosine of theta. So this will be the dot product of the vector P1 times the normal vector divided by the magnitude of the n of the normal vector. That is the dot product between this vector and the direction of the normal vector. Again, you can review that video, it's very clear. Alright, so let's calculate this this vector. You can pick any point in the plane you want. It is easier if you pick the intersection in each one of, well, in whatever axis you want. If you choose the y-intersect, so it would be when x and c are 0. So you have just 2y equals 6, y is equal to 3, and so you have the point PO is equal to 0, 3, 0. You could have used this, or you could have used, if you want to pick the x-intercept, so it would be 3x plus 0 equals 6, so x is equals to 2, so the point 2, 0, 0. Or finally, if you want to choose the c-intercept, you put this equals to 2, so you have 0 plus 6c equals 6, c equals 1, and so the point will be 0, 0, 1. Alright, so we have 3 ideal points that we can choose. These are the more convenient points to choose. Alright, I will begin with, let's say this one, with y, the y-intercept. So this is the intersection with the y-axis. This is the y-axis. Let's say this is the x-axis, and or this is the c-axis better. This is the y-axis, and this is the x-axis. Alright, so the y-intercept is in 0, 3, 0. This means that the plane is intersecting the y-axis at this point. I think that the idea, you have it. I know that in the drawing I cannot draw that. Alright, so the distance between this point and P1 will be the distance between 0, 3, 0, 3, 0, and 1, 1, 3. So the vector P of P1 is equal to, let's say, this minus this, whatever, will be 1, minus 2, 3. This is the point. Now, sorry, this is the vector. So it is I minus 2y minus 2j plus 3k. This is our vector. We want to dot this vector with the normal vector. The normal vector is, as you already know how to find it from the equation of the plane, the normal vector is equal to 3i plus 2j plus 6k. So dotting these two, we have component by component, or you already know why, because we have 9 terms, but I dot j and k dot j and k dot I dies because the cosine of the angle is 0 degrees. And you know that we are going to have just a scalar number because I dot I is the magnitude of this and the magnitude of this times the cosine of 0 degrees. Alright, so here you have I times 3i, that's 3 minus 4 plus 18. So this is minus 1, you have 17. The scalar, sorry, I forgot to divide by, this is the scalar product, this is the scalar product. So is this here. So now we want to divide this by the magnitude of n. The magnitude of n is 9 plus 4 plus 36. So it is 17 divided by 9 plus 14, 13, 49, root of 49, 7. So this is the scalar projection or scalar component of the vector P of P1 onto the direction of the normal vector, and this projection is the distance. So you have that the distance between this point and the plane is 17 divided by 7. If you want, we could have used other vector, other point. Let's see what happens if we take the 2, 0, 0. So now the vector, this will be, let's do this minus this will be minus 1, 1, 3. This is the vector. So the vector is minus I plus j plus 3k. This is the vector. Now we're going to dot this with the normal vector, or if you wish, you want to say we are dotting this with the direction of the normal vector. The direction of the normal vector is n divided by the magnitude of n. So n is, what was? 3i plus 2j plus 6k divided by the magnitude, that is 7. So you need to dot minus I plus j plus 3k, dotting this with the vector 3 over 7i plus 2 over 7j plus 6 over 7k, because this is the distance, this is the direction of the normal vector. So you have 3 over 7 plus 2 over 7 plus 18 over 7, I guess. So sorry, minus 3, this is minus I. So you have again 17 over 7. So it's the same distance. It doesn't matter which point in the plane you pick. Now, the generalized formula, that is, if you want, we can do this in the